In this presentation, we're going to do some practice with the Venn diagrams to help us transition to the survey problems that will be coming up in the upcoming sections. Here's a Venn diagram that instead of having two sets has three sets. We have sets A, B, and C. What I'm interested in this particular problem is, let's just talk about set A. Well, I want to try to highlight set A. Everything inside this circle is inside set A. Set A consists of this region here, which is in set A and set B and set C. Set A includes this region, which is A and B, but not C. Set A includes this region, which is A and C, but not B. And set A includes this region, which is A only. Set A is all of these regions together. Now let's look at the complement of set A. Again, I want to try to highlight set A. The complement of set A is everything in the universal set that's not in set A. So I need to find all of the regions that are not inside set A. This region is not inside set A. This region is not inside set A. This region is not inside set A. And this region is not inside set A. All of these checked regions together represent the complement of set A. The next example, I want to talk about the region or regions that represent A and B and C. I need any region or regions that are in set A and at the same time in set B and at the same time in set C. Well, this region right here is the only region in our Venn diagram that is in set A and in set B and in set C. So this region right here that's checked represents A and B and C. The next example, I want to talk about which region or regions represents A and B. Well, A and B is the overlap of sets A and B. And here I'm highlighting the overlap of sets A and B. These two regions together represent A and B. This is A and B and C. This is A and B but not C. But what we're interested in is A and B. These two regions together represent A and B. Next example is A and B but not C. Okay, let's look at A and B for just a moment. What I'm highlighting here, what's inside this highlighted area, is A and B. Now we want A and B, but we don't want C. A and B, but we do not want C. This region right here is an A and B, but it's not in C. So this region alone is A and B, but not C. The next example is, let's look at the region or regions that represent A or B. Well, remember, OR stands for union. So A or B, A union B, would be take set A and set B and find their union or join these sets together. A or B is join these two sets together. So this region, this region, this region, this region, this region, and this region. All of these checked regions together represent A or B, A union B. Now the reason we're interested in which region or regions represents a set or a union or an intersection of some sets is, as we transition to survey problems, we're going to be interested in how many elements are in set A, or how many elements are in A and B, or how many are in A and B but not C. Remember, the number of elements in a set is the cardinal number of a set. So we're going to start now looking at problems where we're trying to find the cardinal number for a set or a union or intersection of some sets. The first example here is find the cardinal number of set A. That's saying find the number of elements in set A. Well, here's set A. And what we have in this Venn diagram is in each region we have the cardinal number for each region, or the number of elements in each region. Well, set A consists of all of these regions. So we add the 4 elements that are A only. We add the 7 elements that are in A and B but not C. We add the 3 elements that are in all 3 sets, and we add the one element that is in A and C but not B. And so the number of elements in set A, or the cardinal number of set A, is this total. Let's see, 11, 12, 13, 14, 15. So the cardinal number for set A, the number of elements in set A, is 15. The next example is find the cardinal number for A intersect B, or find the number of elements in A intersect B. Remember, intersect means and. We're looking for the intersection or the overlap of sets A and B. And I'm trying to highlight here the regions that are in the overlap of sets A and B. This region is an A and B, but not C. This region is A, B, and C. These two regions together are an A and B. So the number of elements in A and B are 7 plus 3, or 10 elements. Let's look at the next example. This particular question says, find the cardinal number of A and B but not C, or how many elements are in A and B but not C. Well, first I'm going to go back and look at A and B. Here's A and B. But this particular problem says A and B but not C. So we don't want anything that's also in C. So A and B but not C is just this region right here, which is 7. The next example is find the cardinal number for A union B, or the number in A or B. Remember, union stands for or. Well, if we look at A union B is take set A and take set B and join them together. So we need to pick up the numbers in the regions that are in A or B. So we need to add up all of these numbers to find the number of elements in A union B. So we're going to have 4 plus 7 plus 2 plus 1 plus 3 plus 5. So let's see, 11, 13, 14, 15, 16, 17, looks like 22. The next example is find the number of elements in the complement of C, or find the cardinal number in the complement of C, or how many elements are not in set C. Well, here's set C. And we're interested in the total number of elements that are not in set C. These are the regions that are not in set C. Don't forget this region out here. This region is not in set C. So if we add up these numbers, we'll have the number of elements that are not in set C, and it looks to me like 11, 13, 19. Next example, find the cardinal number, or the number of elements in the complement of B union C. Well, first let me go find B union C. I'm going to highlight B union C. I'm just highlighting the external part of B union C. Well, we want the number that are in the complement. In other words, we're trying to find how many elements are not in B union C. We want to know the number that are not in B union C. Well, this region is not in B union C, and this region is not in B union C. So we add those two cardinal numbers up, and so there are 10 elements that are not in B or C. Now the next example is find out how many elements are not in B and C. Remember, this is B and C, the complement. The complement of B and C is everything not in B and C. Well, first let's go find B and C. Intersection means and means intersection. Here's the overlap of sets B and C. Highlighted here in the ink. These regions are in B and C. Well, we want to know what's not in B and C. We're interested in the complement of B and C, or everything outside of there, which will be all of these regions here. So we need to add all of these together. 4 plus 7 plus 2 plus 1 plus 11 plus 6. And if we add all of that up, 4 plus 7 plus 2 plus 1 plus 11 plus 6, Looks like that's going to add up to 31.